let's talk about cross-site request forgery. I don't think there's any announcements that I need, right? I think this is the only thing I announced in the other lecture. Just heads up that first big deadline is coming up Monday morning, homework 1. Hopefully most of y'all are done with that. I don't know how far behind everyone is or ahead. Hopefully you just have that submitted and you're good. But just a reminder, I won't always remind about deadlines, but that one, first big one coming up. Okay, let's talk about cross-site request forgery. Let's do this. So what is this? Why is it so scary? And what are we going to do about it? Those are our questions. And this thing isn't on. There we go. So cross-site request forgery. And in the world of web development, whenever there's cross in the thing, we like to use X in the acronym. I guess it's to be cool, but if you see CSRF, I can't even say that one because I don't say it, but CSRF, XSRF, these are the same thing, cross-site request forgery, but cross-site scripting, cross-site request forgery, the cross is often an X in the acronym. So just a heads up on that, it just means cross. So this is whenever we have a request that's sent from a different origin than the server that we're sending the request to. An origin is a protocol host port combination. So if the request is coming from HTTP localhost 8080 and it's being sent, actually I'll say it the other way, if it's being sent to localhost 8080 on HTTP and it's coming from HTTPS CSE312.com on port 443, that's going to be a cross-origin. If any of those three things are mixed, then it is a cross-origin request or a cross-site request. Those are kind of used a little bit interchangeably. But the origin is different. That's a cross-site request. And we often use this for legitimate purposes. You've probably sent cross-site requests before because you might think, well, I'm visiting this site. All my requests from that site are going to that site. But we do use these. If you've ever built a web page and you have an image and you put an image tag and you do source equals and then you go search the internet for some image, copy the entire URL and put source equals https:// whatever. That's going to be a cross-site request. When somebody's visiting your page, they have to go to another origin to download that image and then populate your page with their image. So you can basically steal somebody else's image that they're hosting somewhere else on the internet. Which is fine, I guess, in that example. Usually your first website, that's what you're going to do because it's easier than hosting your own images. Your first website or web page you ever build, you're probably not going to be hosting your own images, so that's what we all do for our first pages. So that's a cross-site request. Legitimate use for it, depending on exactly what you're doing, copyright and all that crap. But could be a legitimate use. Also, using an API. Next week, starting Monday, we're going to talk about accessing OAuth 2.0 APIs. When we're connecting to this API, we're going to get a request from our user and make a request to an API, and then the user is going to connect to that API. There's going to be cross-site requests to be able to get that working, or just any API that somebody wants to access. They're going to be sending cross-site requests. If you want to embed Google Maps in your web page, that's going to be a bunch of cross-site requests and cross-origin requests to make that happen. So these are things that we can't just say, don't ever allow cross-site requests, because there are legitimate uses for these. But let's talk about the dangers of these things. So what if you visit a site, and we'll talk about some of the mechanisms for now, I'll just say Ajax. You visit a site, it's an attack site, your buddy gets you to click a link, some site they built, and what that site does is makes a Ajax request. With Ajax, you can type whatever the hell you want in your Ajax request and send whatever you want. So they decide they're going to send a post request to Autolab that makes a submission for you. They could access your grades if you're concerned about that. but they can send a post request and make a submission for you whenever you go to your page. So they're going to make a submission to a specific assignment and post that in your name. With Ajax, I got to mention this part. With Ajax, just like the image, the source of an image that I just mentioned, with Ajax, we've done relative paths. You say send an Ajax request to /chat message, and that's fine. But you can also put an absolute path in there. If you say send this Ajax request to https://autolab.csc.buffalo.edu, you can send a request to Autolab through an Ajax request from your page. It's absolutely something you can do, and something an attacker can do. So whenever you visit that page, it makes a submission on your behalf. Big deal. But now they get a second person to click that link. Now all of a sudden you're in my office talking about AI because two of you have the identical submissions, and your buddy's out there laughing his ass off because he just got you failed for the course because, it's just a prank, bro, or whatever. We don't want to allow that. More concerning outside of an academic context is transferring to your bank account. You click a link. That link sends a post request to your bank account and says transfer all of the money to this attacker's bank account. One click and they can grab all of your stuff. If the bank, spoilers, the bank's not going to be vulnerable to these attacks. Autolab's not vulnerable to these attacks. If we're not protecting against these, there's very, very bad things that an attacker can do. Or maybe they're a little less nefarious and they just want to post some dumb stuff to social media under your name. They want to make a tweet or whatever social media site. They post whatever they want in your name. Maybe they send a DM to somebody, some mutual third party. Could get interesting. And logistically, this is how that's going to function. That is the best form of security. The best form of security out there, don't have anything worth stealing. Nobody's going to steal from you if you don't have anything. So I'm not too concerned. If somebody wants to steal, one that trips me up, something that most of you will go through too, is securing my student loan account. Like, do I really need to secure that? If somebody wants to go in here and pay off my loan for me, I'm okay with that. Like, how strong of a password do you want me to create on that account specifically? There's nothing to steal. With this, here's our scenario. You have some awesome project. You deploy it on My Cool project. You start getting millions of users. Everybody's using your site. They're loving it. And one of the endpoints of your site is to make post requests with sensitive data. In the context of our homework, this is our chat messages. Somebody's posting a chat message. And on homework 2, we're going to authenticate those messages. And in chat, we're going to put your username next to your message. So we need to authenticate those chat messages to make sure that it was you who made that message, and we use our auth tokens and hashing and all that good stuff that we talked about earlier in the week. So you deploy this app, and you have something similar. You have a post endpoint that takes sensitive information that needs to be authenticated as this user. And somebody makes an attack site, freebitcoin.com, and they get some sucker to click on their link and go to their page. This page in their JavaScript makes a post request to your app on somebody else's behalf, whoever decided to click on this link. It makes a post request on their behalf, and that post request contains whatever the attacker wants, whatever they want. They've just been hacked. Your user's been hacked. To visualize this a little bit more and make sure we have the full context of what we're talking about, a client, your lovely user that is using your app, goes to your app, creates an account, logs in, gets an auth token. That auth token is set as a cookie, and they're going to use that cookie. Every time they use your site, they send that token, and that token is the only thing your app is using to verify this user's identity. You look at the token, you hash it, you look it up in your database, you pull the account, and you say, this was you, because you own this token. If you have this token, you are this person. I am authenticating this request. Now, the same user, while they're logged in, while that cookie is set, goes to an attack site, clicks a link, they get an email, free Bitcoin, awesome. They click the link, and that's it. They don't have to do anything else after they click that link. Everything else is automatic. As soon as they click that link, the attack is going to be launched. This site, they give you HTML, CSS, JavaScript, browser does its thing, their server does their thing, gets the entire front end runs their JavaScript, which is the scary part here, runs the attack JavaScript, which will send that request to your site. From the origin freebitcoin.com, they're sending a request to my cool project. That's what makes it a cross-origin request or a cross-site request, because the origins are different. And your app gets this request. What's your code going to do? Check the cookie. Cookie's there. It's coming from the user. Cookie's there, authenticated, and whatever the attacker put in that request, you're handling it as authenticated as this user. That's what our apps do. That's what we're supposed to do. That's the legitimate use case. If we get a request, with any request that contains that token, which it will because it's coming from this user, well, asterisk, it won't, but let's leave that for later in the lecture. You're going to treat that as legitimate. So all a user had to do was click a shady link, and they're hacked. Nothing else after that. They don't have to fill out a form or click a button on that page. They just click the link. So when you get those emails with those shady links, who knows what kind of attacks they're launching when you click that thing. Don't click it. I mean, any site that you're using should be protected against this attack anyway, but if you want to be extra careful, don't click those shady links. They're going to at least try to launch these attacks. So it has your cookies. Treat it as a legitimate user, just like your app is supposed to do. If you get a request with that token, it is that user. We don't have other protections outside of that. If they have that token, that request has that token, it's from that user, authenticated. Let's do this. Went well in the other lecture. Hopefully it goes well again today. All right, so I'm going to run my server, localhost 8080. I have my wonderful site here. I can type in chat, hi. I can log in. And I'm logged in. I have my auth token. My server is treating this as me because it sees my auth token and puts my username on those messages like we're supposed to do. Cool. And then somebody clicks this link. I don't have this site hosted, but somebody clicks this link, opens this up. I'm going to open this in, not in, oh, it goes so fast, it's hard to see. But it's going to open with a different origin. Everything's on my laptop, so I have to explain this to show the proof of concept. Change the code first. It's loading from a different origin. I have localhost port 63343. Since the ports are different, this is treated as a different origin. So this request is coming, any request this page makes to localhost 8080 is a cross-site request. So I click this link, I got an email, free Bitcoin. I click the link, I'm like, there's no free Bitcoin. Oh, it's just something dumb. Or maybe it's, one of your friends is like, hey, check out this app I've been working on. And then you click the link, and it just says, hello there. And you're like, oh, yeah, neat, bro. And then, meanwhile, what that did was send a whole bunch of chat messages to some other app or whatever they're trying to attack, whatever is vulnerable to cross-site requests that they're trying to attack, and it made all these messages in your chat. And you go, oh, crap, how'd that happen? So let's talk about how that happened. I want to do a few more attacks first. I'm going to do all the demos and do a whole bunch of attacks, and then actually, I want to explain this one first. We'll do a bunch of attacks, and then go back to the slides and explain what the hell we just saw. So the first one is an AJAX request. These are the most powerful attacks, but we'll see that they are a little bit limited in what they can do. That sounded weird the way I said it, but the browser protects us against them. And what I do here is I have an image tag. It's just going to load some 1-pixel image. You might have seen it when I was on the page. 1-pixel image, and when it loads, we're going to send chat. Now, I could do onload on the body itself, but I'm going to save that for the next thing that I'm going to do. I'll do the onload after that. So this is going to call the send chat function. And send chat, it's an AJAX request. It's cross-site. I'm choosing a different origin by giving it an absolute path instead of a relative path. So it's going to send a message to localhost 8080. It's going to send this message as a JSON string and fire it off. It's basically exactly the legitimate use of the AJAX that we're using in the front end. And that's going to send whatever message the attacker wanted, whatever they wanted to send. And this could be sent from any page. Let's use this one right here. If I'm at CSE 312, and I could put it, I almost did, put it as part of CSE 312, but I thought it'd be weird having that in the Git history and everything. But I'll define this function. Actually, let's change it a little bit. Just to, oh, crap. WebStorm. Not now. Then send chat. And if we go back here, we were able to send that. Notice the username is guest for this one. We'll talk about why. And that did come from cc312.com. That was the origin of that request. And we do get an error message here, blocked by CORS policy, no, whatever this means. We will talk about what that means. But the response was blocked. I wasn't able to see the response with this. I get a CORS error, and I can't see what the server sent back. But the request was still sent. If I change my MIME type, so if I uncomment this line right here, and I say, hey, this is JSON, let's market it properly as JSON. I was sending plain text before. Let's send JSON. I'm going to get a different error. I think it is the same error, actually. Oh, yeah, it is a different error. It's supposed to be a different error. It's going to say the preflight went wrong, something like that. And if I go to my app, that attack did not get through. All I did was change the MIME type. I just changed the content type header. And that attack doesn't get through at all. The first one, I couldn't see the response. The second one, the request isn't even sent. So an important difference on those two things. And then let's look at the other attack. This is the scarier attack by far. AJAX is more powerful, but because it's more powerful, the browser has more protections for us. But the other one is a form. So I have a form here with one hidden input, so it doesn't even display on the page. And when the page loads, I'm going to submit the form. So nobody has to click on a button. It's a form submission that the user didn't have to do anything for. They took no action at all because with JavaScript, I'm submitting the form. In this form, just like our AJAX request, we're going to put an absolute path, which is allowed. That's part of how forms work. For action, instead of saying /chat message or whatever, I'm going to put the whole URL to make it a cross-origin request. It doesn't necessarily have to be, but you wouldn't put a full URL if it wasn't cross-origin because you're just wasting your time. Type in things that don't matter. And introducing bugs because when you switch origins, anyway. Method of post, that's allowed. Encoding type, text/plain, importantly. We haven't talked about encoding types with forms yet, but we will in 2 weeks when we talk about image uploads. There's 3 different encoding types that you can use for your HTML forms. Text/plain, which I used to say you should never use. Actually, I will still say it. You should never use this one. It has no real purpose. It's going to be full of bugs. It's only, even the official documentation says only use this for debugging. But I'll add one thing to that too. If you're trying to attack somebody, if you're trying to launch cross-site request forgery attacks, then I guess it has a use there because I found a good use for it here. Other than that, it has no real legitimate use. So text/plain is one encoding type. URL encoded, that's the default one. That's the one we're using for login and registration. It takes a query string format, URL encoded, and puts it in the body of the request. And the one we'll use for image uploads, multi-part encoding. And that's it. Those are the only 3 encoding types that you can use with HTML forms. If you're using an input of type submit, or well, I guess I don't even have one, or using submit in the form. If you're submitting the form as an HTML form, an important distinction between that and what we do on homework 2 for chat messages. Chat messages is not an HTML form. it's a text field and the button calls JavaScript, which makes an AJAX request. So a subtle difference, but very important in today's context for cross-site attacks. So this is going to send this to with this information, and I carefully use the name and value to make sure that this is going to be properly structured JSON. So it's going to be name equals value. So I'm taking advantage of there's going to be an equal sign here, and then I add a second equal sign, so it's equal. But I have to do something with that equal sign. It has to be part of my request at some point. So I'm hacking the way that text plain is going to be encoded in the request to be able to manually format my JSON strings. There's only 3 encoding types, and JSON isn't one of them. We can't have an HTML form submission using JSON. It doesn't work. That's why we like AJAX. That's why Homework 2 uses both of them. That's why the chat uses AJAX, so we can use JSON. And we don't have to do too much URL encoding or multi-part encoding on Homework 1 at least. Okay, so the user loads the page. Refresh this one. So when this page loads, it happens quick, but I get redirected to 8080. When a form is submitted, an actual HTML form submission without AJAX, the response, remember the response is what the user sees. So the user gets this request sent on their behalf, and whatever the response is to the user is going to be looking at that response. So with the form submission, it actually sends me to localhost 8080, and I'm looking at whatever my app responds with. For AO1, it should be the full JSON thing. I'm just saying nice message for this example. Is whatever my site responded with, and now they're at the other origin. So it was started as a cross-origin request, but the user is going to load up wherever they were sent to. That's important because the attacker can't see the response. So just like the AJAX requests, the form submissions, they can't see the response because they're navigating away. Submitting a form is a lot like clicking a link. You're navigating away from where you were to a new location. The attacker can't see the response. And we have all kinds of stuff. And with the form submission, my username's on those ones. That's what makes those ones scarier. There's more power there. The AJAX, I can't get my name sent. And foreshadowing, but it's because the cookies weren't sent. The cookies weren't sent on those AJAX requests. The cookies were set on the form submission. So form submission, they can get away with a lot more power in their attack. Okay, any questions on the demos? I like these demos. They're fun, but we're ready for slides again. And the demos work. I don't like when the demos crash and burn. I always get stressed out going through them. But they worked in both lectures today, so I'm happy. So a cross-site request forgery attack. How are we going to launch it? A few ways. This one I didn't demo. This one's a bit harder to pull off, and there's not much you can really do with this. But putting the request as the source of an image itself. So when you put the source of an image, if you put a full absolute path there, you're going to make that request to a site, but it's always going to be a GET request. So you can send a GET request with whatever you want, and you can add a query string. Maybe you can get some stuff in a query string, and bless you, it makes some use out of that. But really your legitimate uses of a GET request should just be to get information, right? So if you're only sending the GET request, and you can't make any changes to the server, like if you have a legitimate use for this, for a GET endpoint that uses query strings for the user to send you information, you're opening yourself up to an attack by using the source of an image, because an attacker can put whatever query string they want, send a cross-site request. If your server is taking that query string and treating that as an authenticated request, you're wide open to attacks like this. These are really easy to launch. You just type whatever URL you want as the source of your image. Cross-site attack is launched. And then no image is going to load because whatever the response is probably not going to be an image. But the request already went through. The server already processed the request. Who cares what loads on the attack page? A bunch of broken image links, big deal. Who cares? You already attacked them. Everything's over by the time the victim sees the broken image link. So don't use query strings. Like if that's your use case, please change that to a post request. Put it in the body of the request and protect yourself a bit more from things like this. Query strings aren't made for changing the state of a server or authenticated, just don't do it. But this is a very easy attack to launch, so if you're vulnerable to this, my goodness, all somebody has to do is click an email, not even a link in an email, but just open the email, and if the image isn't blocked, you're just screwed. The next one is cross-site request forgery. The next one is AJAX. The next one's HTML forms. I got this. The next one's HTML forms. This is, in my opinion, the scariest one. This is the most power they can get. But HTML forms are limited. They're limited to get and post only, and they're limited to only 3 different encoding types. So if you're trying to attack an endpoint, if you're an attacker trying to attack an endpoint that doesn't expect one of those 3 encoding types, unless you can get creative with the way plain text works, like the way I did to pretend plain text was JSON, unless you can get creative with that, there's not too much you can do. Only certain types of endpoints you can attack here. And the attacker can't read any of the data. They just sent you away from their page, so they have no chance of reading the response that you got back. Otherwise, they could have some JavaScript that reads the response you got back and then send that information back to their server so they can start stealing data and farming all your data. They can't do that with this form attack because they just sent you away from their attack site. So it's a one-shot deal. They have to get it all in that one shot or else they already lost you. Unless you're dumb enough to go back to the attack site. If you're like, why did Wells Fargo load? That's weird. I was trying to go to free Bitcoin. Then hit back on your browser. Maybe they get another shot. And the last one is AJAX. This is by far the most powerful one for the user, for the attacker. But like I said, there are a lot of protections in place for that reason. AJAX requests, they can do whatever they want, whatever method they want. They can add whatever headers they want, hit any endpoint they want. Just absolute full power with AJAX requests. There's a lot you can do with AJAX. You saw me change the MIME type of my requests. You can spoof a lot of headers, a lot of stuff you can do here. So the attacker's really in control on AJAX. So let's talk about protections. That's how scary it is, how easy it is to launch these attacks. But how are we going to protect ourselves? And the first thing you might think, there is a refer header. When you get a cross-site request, there's going to be a refer header, and you're going to say, hey, this didn't come from my app, and then you block it, right? Which is a reasonable thought. The problem is it's easy enough to spoof this header, and you should be able to spoof it with an AJAX request. I don't know if the browser would override that or not, but these are easy enough to spoof. And part of the theme with protections, as we always talk about, there are no reliable front-end protections. We're not going to trust the front end to protect us at all, even though the next 5 or 6 slides are going to be about front-end protection. We're not going to trust any of it. But there is something called the same origin policy, which does protect us a bit. For most of our internet travels, same origin policy is out there watching out for us, watching our back for us. And the errors that we saw in the console, that was the same origin policy saying, yo, that's not allowed. You can't do that. That's my browser implementing the same origin policy and saying, no, you can't do that. You can't make that request because it's cross-origin and doesn't meet the right criteria. So the same origin policy says, okay, if you're making a cross-origin request, we're going to block a lot of those. And what it's blocking is every single AJAX response. Every single AJAX response, not the requests, but the response, the same origin policy is going to block. So any of our attacks that we launched, if we try to go into the console or try to read the response, my AJAX request when I'm trying to read, ready state 4, status code 200, and I try to say, okay, let me take this response and send it to my server and farm all this data. I can't do that because no response ever made it to the client. They never get to see the response that was sent back. Never gets to them because the browser says, not allowing that. It'll take the response, it'll check the headers, and if there's anything in the headers that it doesn't like, it's going to say, nope, not allowed. This is a cross-origin request. I'm not giving you the response because this was an AJAX request. Certain MIME types. So if it's one of the 3 MIME types that are allowed on forms, it's going to still send out the request. So that's how we got the first request launched, because I was using text/plain. I just didn't specify anything, but I gave it a string, and it treated it as text/plain, which is an HTML form MIME type. So that request went through, but the response was still blocked, but the request wasn't. When I changed the MIME type to application JSON, that's not a valid HTML form MIME type, so that request was blocked. The request itself was blocked. Same origin policy will not block any what it calls safe requests. This is any GET requests. GET requests just go through because you're just getting information. What's the problem? Don't make GET requests that have that are going to be, I can't say that, that are going to be sensitive. If somebody requests, give me some information, you can serve them personalized information. But don't do GET requests that are going to like transfer money, I guess. And post requests that have a MIME type, or post requests that were sent from an HTML form, I should say. I was going to say MIME type of one of those 3 things, but if it's through a form submission, it has to be one of those 3, so there's no other choice. Any HTML form submissions. And HTML form submissions with post, those are the scary ones because it's treated as a link. It's treated as clicking a link and navigating away from the page in terms from the eyes of the same origin policy. So it's like, yeah, that's fine. But since it allows post requests, it gets a little scarier. And those are the big ones we got to be concerned about. That's a typo. That should say SOP. I didn't even notice that in the other lecture or reviewing the slides. So all those HTML form submissions are treated as legitimate submissions, legitimate traffic. Same origin policy, not going to stop us at all. And a recall, since it's very relevant to this conversation, just recall how cookies work with the same site directive. Our cookies, by default, have same site lax set to them. If we override that, we can set it to strict or none. But same site lax is the default for all our cookies. So unless you added this explicitly, your cookies, your auth token is going to be lax. This means, and this is in respect to cross-origin requests or cross-site requests, when are the cookies sent? Lax means whenever you're navigating to that page in any safe request, which is mostly when you're navigating to the page, it's going to send the cookies. But if it's like an AJAX request, then it's not going to send the cookies. This is the username conversation in the demos. So with a same site of lax, when we're navigating to the page, the cookie is sent, which includes HTML form submissions. So when we have that post form that's being sent automatically on the user's behalf, that will include all of our lax cookies, which is our auth token in the demo and in the example, which we kind of want, right? Obviously not in the context of the attack, but in the context of a legitimate user. If somebody's linking to your site and somebody clicks that link, navigates to your site, you don't want them to see the guest interface. You want them to see custom information, as though they're logged in. You want those cookies attached to that request. So the first click, right from the first click, they're seeing their content. You don't want the user to have to make another click, navigate to another page. I mean, maybe you can redirect them and have it kind of in the background, but by default, without doing extra stuff, we kind of want that functionality. So we can go down to strict, but I guess it depends on your architecture and everything. So the cookies were sent on the HTML form submission. So the HTML form attack did have my username because the request did have my cookies, and that attack completely got through. So the same origin policy is implemented in the browser, which means it's front-end security And what do we know about front-end security? It doesn't exist. Can't be trusted. We're never going to trust the front end to say, oh, yeah, the front end's going to do its job. It's going to implement the same origin policy perfectly, and we just won't worry about it. We won't worry about those cross-origin requests. No, we're never going to do that. First of all, some users are still using outdated browsers. Some of them might be using some experimental new browser that some team of developers came up with. Their favorite YouTuber was promoting it because they got paid to advertise it, and they're like, "Hey, check out this new browser." And then you go use that browser, and maybe it has all these policies built into it the way they're supposed to be, but maybe not. And I don't like saying, well, maybe my users are protected. Whatever my users are using, whatever browser, however they're using it, maybe they have some plugins or modifications they made to their browser because they installed some. I keep wanting to say extension. Some plugin extensions don't have the power to do this. Some plugin that disables this kind of stuff, which usually in that case, it's developers, it's us in this room we got to worry about. Our users who are also developers, sometimes what developers will do is they're developing an app and they run into a same origin policy error because they're trying to make a cross-origin request that's not allowed. And usually the use case is they have two parts of their app on two different origins, and they're trying to get them to communicate with each other. And they're having a lot of trouble with it. So they go to Google, they click the first link, and they start cut and pasting things into their terminal until something magically works. And one of those commands was disabling the same origin policy. And they go, hey, my app works now. It never works in deployment. And they're like, it works on my laptop. But it did work on their laptop, but now everywhere they go on the internet, they have the same origin policy disabled. So things like that is an actual use case, an actual case where somebody's unprotected by this without really fault of their own. I mean, debatably, but that can happen. That does happen. So that plugin, well, it got their development environment working on their app, but their app's still broken. So a lot of reasons why this can go wrong. And we can't just say, well, most of our users are protected, so whatever, that's good enough. No, we want all of our users to be protected. We're not just going to leave them out to dry. No matter what the reason why they're not protected by this, we're going to protect the user's server side. That's what this whole course is all about. So finally, out to what we're going to do about it. Everything else was what the attack is and what the browser does about it. What are we going to do about it, specifically in Learning Objective 3 on Homework 2? What are we going to do about it? What are you going to code? And that's cross-site request forgery tokens. We're going to take tokens and math to the rescue to completely prevent any of these attacks. So what we're going to do is issue a cross-site request forgery token when the page loads. A user visits our page. When our home page loads, we're going to go to our HTML template. And from this point forward in the semester, you'll be making more and more modifications to the front end of that site. I gave you the starting point, which you could use out of the box for homework 1. But as we go for different homeworks, there'll be parts where you got to modify that. This is one of them, is modify the template to have a second or third, depending on if you use placeholders anywhere else. But add another placeholder for the cross-site request forgery token and replace that with the token that you generate for that user. So when you serve up the HTML for a user, that HTML is going to have a random token, and you should aim for your 80 bits of entropy at least for these tokens. Generate a random token for them, embed that token in the HTML that you send to that user, and this is authenticated users only, and then store in the database that token and say, this is a cross-site request forgery token that I issued to this particular user. You want to associate it with a particular user. And then whenever you get a request, well, I guess we're not there yet. And then usually put this in a hidden form input. This is my recommended way to do it. Since we're using AJAX, you can use whatever you want for this. If you want something else, I'd still recommend a hidden input. It just makes the logistics a little easier, in my opinion. And don't expose this to the user. The user shouldn't know or care that you're using cross-site request forgery tokens. They don't need to see it on the front end unless they're looking at your source. They can see it if they want to, but they shouldn't have to. And then whenever you make a form submission, or whenever you, in our case, make an AJAX request, add this token to those requests. Have some JavaScript that reads the HTML, reads the DOM, not the HTML, but the DOM, gets that value of that token and puts it in that JSON that you're sending for a chat message. Now, when you get a request from a user, you should have auth token from a cookie and cross-site request forgery token in the content, in the body of that request, in the content of the request. You're going to take the auth token, hash it, look it up in your database, pull the user's record, which will now contain a cross-site request forgery token. Take that token, check it against the token that you just received, and see if they match. If they match, they're good. If they don't, this might be a cross-site request forgery attack, and you don't respect that attack. Now, for a legitimate user, this is all in the background. It's all automatic, and the user just makes a request. The token comes along for the ride. Your server checks the token, and everything's good. Nobody knows or cares that you're using these tokens. For an attacker, they can't get a hold of these tokens. They can't get the tokens. Because what they can do, what they can try to do, is go to your site, get the HTML, grab a token, and then use that token in their cross-site attacks. But that token's going to be associated with their account, not the account of the person they're trying to attack. That's why we have to link these to a specific account. So when they send that forged attack, that cross-site attack, it's coming from the user. It could have their auth token, but it's not going to have a matching cross-site request forgery token, because you can only get those if you're this user visiting the home page and getting that HTML and reading that HTML or reading the DOM. So now the attacker's not going to be able to get both of these in their spoofed requests. They can try to do things to send the GET requests to the home page to try to get the token, but most of those GET requests, they're not seeing the response. If it's a form attack, they just sent you away from their page. They can't see the response. If it's an AJAX request, the response is blocked. Even if the request goes through, the response is blocked. So they can't access a legitimate token for that user unless you're really vulnerable to things. If it's in the source of an image, I don't know if there's a way in JavaScript to read the response from those. There might be ways, but this is a pretty foolproof way to block those requests, cross-site attacks. And then putting it in a hidden input. So I like input. I didn't even put type on this. I guess we don't need type if it's hidden. But make it hidden, and then put the token with a placeholder, and then replace that placeholder with your token value for that specific request. Now someone visits your page. They get a cross-site token. The attacker has no simple way. I'll leave it at that. They have no simple way of reading that token, of getting that token. So they send this cross-site request. Your server says, okay, you are this person. I see that from your auth token. Let me see your cross-site request forgery token. And there will not be a legitimate cross-site request forgery token attached to that request. Your server says, nope, this is no good, and doesn't respect the request at all. Sends a 401, actually it would be 403, I guess. I don't know. It sends some 400 level response. Any questions on these tokens? And like other things, I'll stick with what I put in the homework document. I didn't put anything about hashing these things. They're not as sensitive as our passwords and auth tokens. If somebody steals a cross-site request forgery token, they still have to launch a cross-site attack, get that specific person to click a link. Like, there's a lot that still has to happen. Maybe they should be, but I don't know. I didn't make it a requirement. Y'all are pretty quiet in chat, too. The other lecturer says so much stuff in chat, I have to say, I'm ignoring chat now because I got to get through these slides. I don't know what I prefer more. It's fine either way, I suppose. Okay, but I will get through the slides at least, for what it's worth. So CORS is kind of the other side of this, cross-origin resource sharing. CORS is something that can lax the same origin policy if needed. I started this lecture with there are cross-origin requests, cross-site requests that are legitimate, that we want to do, that we want to use out there on the internet. And CORS is a way for us to say, yeah, you know what, same origin policy, maybe just chill out a bit. I want this to be a cross-origin resource. I want to be able to have this accessible from other places. If you're hosting an API, you want cross-origin requests all day. If you have an image in the image example, that image you would label as allowed, with CORS. You would say, allow this for cross-origin requests. Let everybody host my image. I'm fine with that. And we do that through headers. We would set an access control allow origin header to star, and that's going to allow any cross-site request for that resource. Anybody can access it. And the AJAX requests, they'll see the responses. It'll just be fully open from any origin. And the star we can replace with specific origins. Star is a wildcard that means absolutely everybody can access this resource. If we have a use case where we have an app that runs across two different origins and they need to communicate with each other, we have our app and then the app consumes an API. That API, we might set cross-origin to just the domain of our legitimate use and not let everybody on the planet access that API directly through cross-origin requests. So sometimes we want to do this. If you're using the star, be careful with it. First of all, understand everything we talked about today and what that star does and why you might want to do it. And if this does make sense, maybe, sometimes that is something you just want the resource available for cross-site requests, go for it. Don't do this if you don't know what's going on. I see a lot of Stack Overflow questions or answers usually where somebody says, I'm getting this same origin policy error, or I'm getting this CORS error. The error messages say CORS. I'm getting this CORS error, like what do I do to fix it? And some of the answers will be like, oh, just slap this header on your stuff, it's fine. And yeah, the error goes away, but you got to understand what you just did. What have you done when you do that? You're just opening yourself up to cross-origin requests. And again, if that's the specific use case for your app, like some of the answers are legit, like, hey, yeah, this is what you do if that's your use case. You just got to make sure that